So quickly we'll be doing K-means and K-Medoid numericals in this video. So given in this K-means numerical, we'll begin with K-means. We have been given a data set that looks like this 2, 4, 10, 12, 3, 20, 30, 11, 25. Now given to us, the new information is that the clusters that we're going to take is 2. And given also in this question is that mean 1 and mean 2 are 3 and 4. If they are not given, you can assume random means. Okay, random means can be assumed if not given. Okay, now moving on with this question, one thing that you need to keep in mind while solving this question is like how I'll explain only how this question is solved. Okay, so we go about dividing the data set into two clusters. Okay, now depending upon the mean. Okay, I'll show you if when I solve it will get more clearer. So what happens is if the mean is 3, we take out of the whole cluster the values that are closest to 3 and make a cluster out of them, and the values that are closest to 4, that becomes another cluster. So let's start solving this. So for our first, let's call this IT1. Okay, we'll just refer to as iteration 1. Iteration 1, what happens? We have K1, we got K2. Okay, value closest to 3, 2, 3 minus 2 is 1. So let's put 2. 3 minus 3 is 0. Okay, now once that is done, let's start at 4. 2 is done 4. I should have gone with 4 only directly. 4 minus 3 is 1, but 4 minus 4 is 0. So 4 becomes part of cluster 2. So cluster 1 is basically related to a mean 1, and cluster 2 is related to mean 2. So 4 becomes a part of cluster 2 because 4 minus 4 is 0 rather than 4 minus 3, which is 1. Okay, then we go about 10. 10 minus 3 or 10 minus 4, it's closer to 4 because 10 minus 3 is 7, 10 minus 4 is 6. So 10 becomes a part. So now we can get the pattern that 12, 20, 30, 11, 25 all are more closer to 4 than they are to 3. Okay, so that is your first two clusters formed. Now we get the new mean and the new we get the new mean 1 and mean 2. Mean 1 would be basically 2 plus 3 divided by 2, that would be 2.5, and similarly this would be, as I've already calculated, this would be 16, right? With those new value, let's move to iteration 2, where we'll form our new K1 and K2, right? Cluster 1 and cluster 2. Now 2.5, we'll again have a look at we can continue from here only. 0.5, 2, 3 is also a part. Now the question arises for 4. Is 4 a part or not? Right? So is 4 a part? Let's check. 4, 2.5, which would be 1.5. 1.5, 4 is obviously closer to 2.5 than it is 16. 4 becomes a part. Let's open 10. Is 10 closer to 2.5, 8.5 or 6? 16 minus 10 is 6, or it's 8.5. So 10 becomes a part of this. Now if 10 is the part, then obviously all of the trailing numbers are more closer to 16. So those become a part of cluster 2. That is our two clusters formed. Now we calculate our new mean 1 and mean 2. Let's calculate mean 1 and mean 2. Mean 1 would basically be 2 plus 3 plus 4 divided by 2, which would be 3. Mean 2 would be 18, right? We repeat the step again in our iteration 3, where K1 and K2, 2, 3, 4 are definitely closer to 3 than they are to 18. Question arises for 10 again. 10 minus 3 is 7. 10 minus 18 is 8. So 10 becomes a part of this set, right? 12 minus 18, 6. 12 minus 3, 9. Obviously 12 becomes a part of K2. So if 12 is a part of K2, then obviously 20, 30, 11. For 11 we can check once again. 11 minus 3. 11 minus 3 is 8. Okay, but 11 minus 18 is 7. So 11 becomes a part of cluster 2 because 7 is less than 8. Now again we calculate a new mean 1 and mean 2. Let's have a look. Let's end this over here. Mean 1 and mean 2 would look something like 4.75, 19.6. Cool. We are at the 4th iteration. So at this point you'll be wondering, when does it stop? It stops when the sets don't change, the clusters don't change, and the mean doesn't change. So we'll do the 4th one. 2, 3, 4, 10, 11, 12, 20, 30, 25. If you calculate, this is what you're going to get as cluster 1 and cluster 2. We get a new mean 1 and mean 2. Mean 1 is 7, mean 2 is 25. Now if you check 25 being the mean, only these are going to be closer to mean 2, and these are going to be closer to 7. So subset 5, cluster 5 for iteration 5 would be similar with similar sets leading to similar mean 1 and mean 2. So there will be no the point of calculating for the 5th time is makes no sense because it is going to be the same. So here we can go about saying convergence criteria met, right? Convergence criteria met, that is there are no changes anymore, hence these become our final clusters. These are our final clusters. So that's the answer. So I'll just write them down. Final clusters, right? So that is K means done, right? That is your final answer. K1, K2, just write them down as an answer. That is your question done. Now we'll be doing something called as K-Medoid. I have the question in place already for you guys, for my convenience as well. Just track the question. So now we'll be solving a numerical known as K-Medoids, right? Now that we're into the question, I want you to only focus on these two columns. This is your question. I'll just write, and I'll just label them x4, x5, x6, x7, x8, x9 and x10. Okay, this is your question, right? Now the question has also inside the question it is mentioned that we have to take k as 2. Okay, once k as 2 is given, what we do is we assume two centroids because k is 2. Now our assumed centroids are c1 and c2, which are 7, 4 and 3, 4. So our c1 is 3, 4 and our c2 is 7, 4. Okay, now everything goes in order. Once this is step 1 done. Okay, now what is step 2? Step 2 is to calculate the cost. Okay, To calculate the cost, we need to find the dissimilarity. Okay. How do you calculate the dissimilarity? The formula is simple. To calculate these two values, that is dissimilarity for C1, this for C1 and this for C2, the formula is x1 minus x2 plus y1 minus y2. Okay. So for C1's case, for C1, x1 equals to 3, y1 is 4. Let's try for the first one. You do not have to show this like this, okay? I'm just doing it for you. Let's do it for x1. x1 as in this iteration x1, okay? So how do you do that? 3 minus 7 as it's given here. I'll just zoom out a bit. 3 minus 7 plus y1 is 4 minus 6, x1 is 7 comma 6. Okay, what do you get? 7 minus 3 is 4 plus 4 minus 6 is 2, 6. That is how we got this. Similarly, now we continue solving for the whole C1, and then we'll solve for C2. C2 में x1 being 7 and x2 being and y1 being 4. This is x1 here. This is, sorry for the thing. That 4 is your y1, obviously. Just let it be, that's understandable. Okay, so once that is done, we move on to your step 3, where you calculate O dash. Okay, what is step 3? Calculate O dash. Step 3 is to calculate cost. How do you get cost? Cost is basically the value which is minimum of these two. Okay, so I'll write that down. Cost is for some reason this is lagging. Cost is, I'll explain. Cost is minimum of these two. 6 comma 2 hai, so this becomes your 2, as 2 is minimum. That becomes part of your cluster 2. 3 comma 7, 3, 4, 4, 6, 2, 2. So whatever is minimum. Once that is done, you calculate the total. Total being 20 over here. Uske baad, once that is done, you check ki is O dash a thing, or you take a new medoid out of the remaining ones. ठीक है, इनमें से take a new one out of the non-medoids. Take a new medoid. Let's say x8 we took as a medoid. Then you again calculate the cost, which would basically be this formula again on those 7 minus 7 plus absolute of 7 minus 7 plus 3 minus 6. That would give you 2. So you calculate that. ये column आएगा. That would be 3. So ये column आया. Now to calculate cost of O dash, you do minimum of C1 and O dash. Okay, that is how you get this. Then you calculate the total cost, which is 22. Now 22 minus 20, why is this lagging, is 2. You understand? 22 minus 20 is 2, which is greater than 0. Then the previous centroids that you found, medoids that you found, were right. Okay, so that becomes your final answer. I'll attach the PDF to the whole solving below in this video description, so you can check that PDF for stepwise understanding. I'm just overgoing the sum right now over here. Okay, Varna, if the value is not greater than 0, you take a new O dash. and calculate the distance again, dissimilarity again, and then calculate the cost again until you find a cost that is greater than 0. So that is k means and k medoids done.